The pandemic has forced us
to adapt to a new normal way of life. One of these things being having to wear a face mask in public and enclosed areas. This habit, although uncomfortable, is imperative to seeing the end of the pandemic. Bereket, Michelle and I worked on a project for our school community to help stop the spread of the virus. We managed to create an AI face detection algorithm that uses a camera to detect whether the subject is wearing a mask or not, and alert the user if not. I will now pass on to Bereket and Michelle to explain and demo the product. Thank you.
We used Python programming language with other dependencies such as OpenCV, NumPy, TensorFlow, Keras, and SciPy. We wrote an algorithm and trained it to learn the difference between pictures that have a face mask and do not have a face mask. So this was done by feeding our deep learning face mask detector model with thousands of pictures that display people with or without a face mask. So these are pictures of people that do not have a face mask, and these are pictures of people that have a face mask. So our algorithm is able to learn what it means to put on a face mask or not to put on a face mask based on these pictures. So with the help of a face detector model, we're able to detect a person's face and tell if that person is properly putting on a face mask or not. Thank you.
Now, to demonstrate. As you can see, the code successfully detects whether or not somebody is wearing a mask by putting a green box around their face and topping that off with the word mask and a percentage. This percentage is the likelihood that the program is correct. So when you see the word mask in 100%, it means the subject of the video is wearing a mask and it's 100% likely that this is true. Without a mask on, the code surrounds the face with a red box and says this person has no mask, as well as adding the percentage that is the likelihood that the program is correct. So a no mask in 100% means that there is a 100% chance that the subject of the video is not wearing a mask. Now, in a real life situation, people would not be sitting in front of the camera. Instead, they would be walking towards the camera. And so let us demonstrate that as well. As you can see, if I am away from the camera walking towards it and not wearing a mask, it still says no mask with the red box around the face. Yet, if I have a mask on, it detects this correctly by surrounding my face with a green box and saying mask. Thank you and have a lovely day. This has been Bereket, Paul, and Michelle.
Hello SOS-HGIC, I'm Tyron Chong and I'm the Program Manager for the robotics sector. Now in this sector, we work using the EV3 brake, which is a simple yet powerful machine together with Lego pieces to create unique technologies that solve modern world problems. Although COVID-19 disrupted our normal club meetings, however, we work together in our various bubbles to work on different aspects of the project's innovative systems. And I'll start by showing you the aspects of the project that I worked on with Jaiju and Senna.
Good afternoon, HGIC, and this is the Trojan Boys Probotics project, the robotic assisting hand. So we wanted to focus on a problem that is common in the world and something that certain people might overlook, which is the loss of motor function in the human body. Many people go through accidents that cause them to lose function of certain parts of their body, and we wanted to help those people with our robotic assisting hand. So the way it works is that it uses touch sensors to detect change in motion, and once that motion is detected, they will either move up or down depending on what is the touch sensor pressed, and then they have the computer and they are linked to motors which control the movement, and we have a trap to catch the object that is picked up or being carried to somewhere, and then we have the main CPU that controls it all. So as you can see here, I've turned my hand to the side, and I am now attempting to press the 2 touch sensors at the same time to grab this vitamin C case. So by pressing them at the same time, I'm able to grab the vitamin C. It is blocked from falling off by the cage that we created, and I'm able to transfer it maybe to the next desk or over easily with just a simple press of 2 buttons once again. And that's how the Probotic Assisting Hand works.
Hello everyone, and this is the Spartan Boys project. So the Spartan Boy decided to make a project which consists of 2 parts. Now the first part is a robot arm and the second part is a conveyor belt. So the main aim of the robot arm is to pick pieces and it places it on the conveyor belt, and the conveyor belt distributes those pieces into colors. So that's the main motive of our project. Now a real life example is in the rice factory. They use a robot arm to pick up rice and places it on the conveyor belt, and the conveyor belt distributes them into brown rice and white rice. So this is our project.
Hello everyone, I'm Edwin Abdo and I'm the Electronics Program Manager. And today, the electronics sector has decided to come up with projects that will help to tackle the coronavirus pandemic. First, we have decided to reduce contact completely. Therefore, we created an automatic water dispenser that is completely anti-touch. Same applies to an anti-touch bell.
The anti-touch water dispenser. We used an inference sensor which senses motion. Therefore, when the sensor detects signal, it turns on the pump. Finally, we will have a dispenser that does not need physical touch for water to flow.
So, what will be the point of touching the door or knocking on it if we're trying to reduce contact? With this, it comes the anti-touch doorbell, where as long as the object is in the range of the program code, then the bell will ring inside.